So here's one more example on insurance pricing, and then I promise we stop. There's enough of it, right? I'm sure by now you're thinking that. So here in this example, again, this is the other one that I talked about, which is the $25,000 face value policy, and then assuming a 2% rate. You can, I'm going to just quickly walk through it, not spend as much time on it. The answer was the lump sum payment due at 35 would be $284.84. That's sort of the lump sum payment due at the starting point, which is the 35-year-old, for at time 35 for the 35-year-old. The question was then, what would be what would be the equivalent annual annuity premium if the person chose to not pay off the entire thing, or it was too large an amount? What if you want to break these up into equivalent annual annuity payments, which is what most of us do with insurance policies, is that we make annual payments to the company as premium payments and not usually buy it all in one lump sum. So the question would be, what would be the equivalent annual annuity payments whose present value at 35 would be $284.84. So for doing that, again, following the same expected payoff calculation that you've seen before, you just simply calculate the expected the claims at each of years 36 through 39, or at 40, 36, 37, 38, 39, and 40. You get the present value of the claims, and then that gives you that $284 when you sum it up at the starting point, $284.84 that we've already talked about. Now the second part of it, which is how do you now decompose this $284 into equivalent annual annuity amounts to keep your policy going. And that's where what we do again is, and I'm going to quickly walk you through, not spend as much time in detail. Again, here's a timeline to make my point. The present value at 35 is $284.84. And then you think of these unknown annuity amounts that we have to compute as X, representing these X's at 35, 36, 37, 38, and 39. And so when we write it out in annuity form, what we can do is we can then calculate the present value factor representing this X would be by itself. So it'd be X plus the X times present value interest factor for annuity. Remember, this will be a 4-payment annuity, so N will be equal to 4. And the interest rate, I believe, was 2%, if memory serves me correct. And therefore, you calculate either from tables or from the formula for the present value factor that you already know. You'll calculate that amount. So X plus X times the present value factor equals $284.84. That's an algebraic equation. If you then solve for X, your answer would be $59.25, which represents the annual payments that you have to make, with the first payment starting right now. That's the key. First payment starts right now, $59.25, and then your policy gets activated, you're covered, and then every year at the beginning of the year, you will have to make your payments of $59.25 for the next 5 years for you to be covered. Good luck.